Okay, this one is ugly debugging. No massive insights here or anything. It's just if you are debugging, the aesthetics of your debugging doesn't really matter. So just, I guess, to admit out loud, that I don't do anything particularly clever when I'm debugging. I'll just use brute force and ignorance, whatever works. I'll just get there in the end. So I'll just admit that I do it so that you don't feel shamed when you do it as well. So let's say what often happens for me is that I have a case that there's an assert that fires. I do a little quick debug and I find out that the actual assert that fires happens on maybe the 700 creation of an object. That's the one that asserts. So, what I really want to do is I want to debug from the construction of that one particular one that crashes, and I want to find that one. I want to put a breakpoint there, and I want to go from there. So, I just add in the fprints, I dump out the dis pointer on it, I put in a static int, I increment the int each time, and I find out that it asserts on whichever one it asserts. I search back in the log, my Sido log, to see what number was that static int when it was constructed. If it was like 452, whatever it was, I just go back up to it. I put in like, if it hits this value, fire my debug line at that point. So I have my debugger will fire when it hits that number. For the purpose of the demo, I've added in this sophisticated get-env thing, which I don't actually use, but just to show that how you could do it without having to recompile each time. Anybody who's actually really good at this stuff probably uses RR, records the entire session, figures out the information they use, and then replays it. Or you could just use brute force and ignorance, and you will be finished pretty quickly. Same kind of scenario, something is leaking, you want to know which one is leaking, you have your little simple dump of your pointer at the construction and destruction, dump it out, sort it, unique it, you find out which one is the one that's not consistent with the rest of them, go back to the log and you find out that it's number 457, and you go back, you put your breakpoint there, and now you're debugging the one that matters, whichever one's unbalanced, and you just move on from there. Just aside, I always use output to standard error because it's unbuffered. The other ones are buffered. I don't want to deal with the complexity of flushing things or putting things in sequence or anything like that. So, I always use standard error and I just get less surprises. Always have, always will. Hardware watches, very, very useful. Back to the example we have there, we have this particular class, we're on the particular instance that we know is going to be one that matters. Maybe it's reference count. We just put a breakpoint on when the contents of the variable changes. These are all from GDB. Another tip there is that if you have GDB and you want to see this graphical user interface, it's TUI enable. It used to be something like Win enable. Now it's TUI enable. Next page. Thank you. Yeah, and if you're watching something, apparently you can use watch minus location and it'll actually work out correctly for you what you want to watch. But I always just print out the actual address of the thing I'm looking for and I copy and paste watch, and I dereference the actual number that comes out of it because, I don't really trust any of the sophisticated stuff. Ugly debugging, you want to know where something has been caught and thrown. GDB has catch, throw, and catch. They'll catch where exceptions are thrown and where they're caught. That used to be as good as you can do. Now you can actually catch on the name of the exception and it'll do the proper lookup of the name as well. So you can just look up, let's say, catch runtime exception, and it'll actually catch, com sun star, runtime exception. It'll do that lookup for you now as well. Didn't in the past, it does now, worth knowing that it works much better. In extremis, you can script GDB. There's a couple of scripts in there you can look at for examples. Dump the backtrace of every try and catch, dump it all out to a log, analyze that text log afterwards. There's this ref count one as well. Similar stuff, add in some extra stuff that's as crude as the stuff I showed earlier. Find the acquire releases and then sort them by which one is most likely to be the one that leaks. So it's rough debugging, but gets you there. If you're doing graphical debugging and you're looking at things that involve mouse pointers and mouse events, just get a second computer and log in and you're done. If you want to get really rough with things, you're in the VCL one, can be adapted for the other ones. You can dump out every single thing that draws, can be dumped out to an individual PNG, and you can breakpoint where exactly that actual square is drawn if you're looking for something weird like that. And the 450 iteration of drawing has a square. You put your breakpoint there and you can move on. And the last one then is that if you want to get, if you want that to shut up, that'd be better. Yeah. If you want to search for an example of something you can make, you can abuse the crash testing and you can put in an assert to find an example of the document you're looking for. We'll run the crash testing. It'll fall over as a case of something that you're looking for. You take out your temporary assert that you use to find an example of something. And that's how you can use crash testing to find something interesting for your analysis. Okay, thank you.